This is Moser with Limiting and Excess Reactants, the mathiness. By the time you're done with this video, you should be able to determine which is the limiting and which is the excess reactant, and how much of the excess will remain when given the mass of two reactants and, of course, a balanced chemical equation. Now, in order to do this, you already need to know what are reactants and what are products. You need to know how to derive a mole ratio, how to find molar mass, and how to use both of those skills in the course of doing basic reaction stoichiometry. So, I hope, you already know what stops a chemical reaction, when the limiting reactant runs out. And you understand that the excess reactant is the one that doesn't get used up. But what we want to know is, how do we figure out which is which? So let's take this reaction. We have lithium chloride reacting with silver nitrate to form lithium nitrate and silver chloride. If we're given 50 grams of lithium chloride and 150 grams of silver nitrate, which one's limiting? Which one's excess? And how much of that excess reactant is left? Well, of course, because we're talking about reaction stoichiometry, we're going to do a factor label. And because we're talking about limiting and excess reactants, the only things that we're going to be comparing to one another are the reactants for now. The products should not appear anywhere in your factor labels. Not yet. So, factor label starting with those reactants. Well, obviously it would be helpful to have the molar masses done, so I'm going to do that real quick. And I've just kind of shrunk the question, rearranged it, and stuck the molar masses in here. So as I said, this is all going to be comparisons between the reactants. So we're going to start our factor label with either reactant and the amount that we were given of that reactant. Might as well start with lithium chloride since it's listed first. So what goes in our first box? As always, are given. And we know that we have to have units and chemical matching here, so I'm going to go ahead and put in grams of lithium chloride. And I know that I want to get into moles of lithium chloride, so I'm going to convert to moles of lithium chloride. Now, here's a question. Where are we going with this? Well, what we want to see is how many grams of silver nitrate can be reacted fully by that 50 grams of lithium chloride. So what we're going to end up in is grams of silver nitrate. It's always nice to know where you're driving. It helps. Alright, so I've got moles of lithium chloride, grams of lithium chloride. I'm converting into moles of lithium chloride. I know that units and chemical have to match here, so moles of lithium chloride. And I'm ready to do my mole ratio. Ah, yes, the heart of any reaction stoichiometry problem. Well, the ratio here is going to be moles of lithium chloride to moles of silver nitrate. Alright, and since I want to end up in grams of silver nitrate, of course, units and chemical have to match here, moles silver nitrate, and I'll end up in grams of silver nitrate. Very good. Now, what numbers do I plug in? Well, remember that nothing except the number 1 ever goes in front of moles unless it's a given or a mole ratio. And the number of grams in 1 mole of lithium chloride is 42.39. If I stopped after that box, I would be in moles of lithium chloride, but that's not where I want to go. I'm going to erase my heart to make things a little clearer. My mole ratio, as given by my coefficients in the balanced chemical equation, is 1 mole of silver nitrate to 1 mole of lithium chloride. And then my last box will be a conversion back into grams, but this time in grams of silver nitrate. So I know that 1 mole of silver nitrate is equal to the molar mass of silver nitrate. So I have my factor label set up. I'm going to do a quick check to make sure that all my units cancel. Grams of lithium chloride, moles of lithium chloride, moles of lithium chloride, moles of silver nitrate, moles of silver nitrate, and I end up in grams of silver nitrate. Fantastic. Now, for a raw answer, I have 200.377, etc. grams of silver nitrate. Huh, great, I got a number. What the heck does it mean? Oh. Well, what we're saying is that 50 grams of lithium chloride is capable of reacting a full 200 grams of silver nitrate. But did we have that much silver nitrate? No. we only had 150 grams of silver nitrate. What's going to happen to the silver nitrate? It's going to run out. So we now know that silver nitrate is our limiting reactant. That means by default the lithium chloride would be our excess reactant, but we'll have to do another factor label to figure out how much lithium chloride remains. Now, if that quick walkthrough that I did to prove that silver nitrate was the limiting seemed a little fast for you, I have a gift for you. It's this sheet of paper, which will be linked on the chapter plan, and it's the sentences for limiting and excess. Never get it wrong again. You literally write this sentence when you're doing limiting and excess reactants. And let me copy the problem over. And the sentence we're going to use is right here. So, number 1 is your given. That is the given that you started this factor label with. So I'm going to write in here 50 grams lithium chloride. Could react. Number 2 is the answer you got for this factor label. So here's 1, here's 2. 50 grams of lithium chloride could react 4 grams of silver nitrate. However, we have, and this is where you're going to go back to your problem and look at how much of that second reactant you were given. Therefore, we will, well, if 2 is greater than 3, we're going to run out of that, or have some left over if 3 is greater than 2. So in this case, and there's my third blank, 2 is greater than 3. We're going to run out of silver nitrate. Now let's do the factor label that will show us how much lithium chloride we'll have left over. In order to do this, I'm literally just going to set up another factor label, but this time I'm going to start with whatever my limiting is and the amount that I was given. Okay, so I'm showing that 150 grams of silver nitrate, when converted to moles, going grams of silver nitrate, canceling, moles of silver nitrate canceling in a mole ratio, moles of lithium chloride canceling and ending up in grams of lithium chloride, 150 grams of silver nitrate could react 37.429 on and on and on grams of lithium chloride. Aha! Let's write our sentence. 150 grams of silver nitrate could react 37.4 grams of lithium chloride. However, we have 50 grams of lithium chloride. So, we will have 50 minus 37.429, etc., which comes out to 12.6 grams of lithium chloride left over. Okay, that's it for this video. I'll do a couple more with single problem examples. You'd be wise to watch them. Good luck. Grab the practice.